Hello, my name is Akshay Ravichandran, and I'm a member of the Teen Advisory Board for the Howard County Library System. So today I'm going to talk about how to factor polynomials. So let's first start off by asking the question, what is a polynomial? A polynomial is a mathematical expression with multiple terms. These expressions generally have several terms that have different powers of the same variable. These expressions can be factored in order to be convenient for future operations. So let's begin. The first way to factor out is finding the greatest common factor. So let's start with the first expression. The greatest common factor in this expression is 2, as these two terms can be divided by 2. So we're going to write as 2 times 2x divided by 2 is x, and 4 divided by 2 is 2. That is our factored form. For the next expression, not only can we factor out a coefficient, we can also factor out a variable. So in this case, we can factor out 3 as well as an x, as all these terms have an x. So our greatest common factor would be 3x, and then we're going to divide it by each of the terms again. So 3x cubed divided by 3x is x squared. And then for the second term, 9x squared divided by 3x is 3x. And the last term would just be 3. All right. For the third expression, we have two variables that we can factor out. We can factor out an x cubed, as both these terms have at least an x cubed, as well as a y, because both these terms have a y as well. So our GCF would be 4x cubed y, and we would multiply this by y as 4x cubed y squared divided by 4x cubed y is y minus 2x. All right, let's go to the next way of factoring. The next way of factoring is through trinomials. There's a special way to factor these. Ultimately, what you want to do is find two factors for the C term. In this case, 4 and 2 are certain to two of the factors. You want these two factors to add up to this B term right here. And so in this case, 4 plus 2 does in fact equal 6. Since the coefficient in this A term is 1 right here, we can simply write this as a factor form as x plus 4 times x plus 2. That is the factored form. For our next expression here, we have a greatest common factor that we can take out, the 2. So we can further simplify this by 2 times x squared plus 7x plus 12. Now we can do the same thing from what we did here and find two factors of 12, 4 and 3, which these two multiply to make 12, and these also add to make the coefficient here, which is 7. All right. So now we can simply write this as 2 times x plus 4 times x plus 3. That is the factored form. For this last expression here, the coefficient of this A term is not 1, unlike these previous two expressions. So what we can do is multiply this A term 2 by the C coefficient, which is 10. Now we're going to find two factors of this 10 that add up to the B term. In this case, 10 and 1. All right. So now instead of writing how we factoring it the way we did for the last two, we can group these and split it by splitting the middle term and putting 2x squared plus 10x plus x plus 5. Now, using grouping, we can separate these two sort of expressions and factor out what we need to do. In this case, we can factor out the GCF of the first expression of 2x, and we'll get 2x times x plus 5, and another 1 times x plus 5. Now the GCF of these two is x plus 5 times 2x plus 1. All right, the next method of factoring, identities. So as you can see with this chart here, we have certain identities. A plus B quantity squared is equal to A squared plus 2AB plus B squared. A minus B quantity squared is equal to A squared minus 2AB plus B squared. And A squared minus B squared is equal to A plus B times A minus B. So these identities help us solve these factors way more easily. So in this case, we can see that this number, this term can be square rooted, and this number is also a perfect square. So now what we do, and we have a negative sign here. So now what we do is we take the square root of this A term, which is 2x, and the square root of this B term, which is 3. Now we have our A and our B. So now we can simply write this expression as 2x plus 3 times 2x minus 3 using this identity. For this next one, we have an A term that can also be a perfect square, 2x. And we also have this B term right here, which is also a perfect square of 2. Now, we have to see if we can write it as A plus B quantity squared by checking to see if this A term times the B term times 2 is equal to this middle term. And so 2x plus 2x times 2 times 2 is equal to 8x, which indeed is this middle term. So now we prove that this identity can be used. We can simply write this factored form as 2x plus 2 quantity squared. All right. For our last factoring method, it is simply another form of grouping similar to what we did 2 slides ago for the last equation. So what you want to do again is split these into like 2 separate sort of expressions and take out the GCF. So in this case, you can take out an x squared. So x squared times 2x minus 3 plus, you can also factor out a 9 from this. So 2x minus 3. Now using grouping, and now using finding the GCF of these two terms, we see that you can take out 2x minus 3 times x squared plus 9. And now finally, we can do the same thing for this last expression. Factor out x squared, you get x plus 1. And then you can also factor out a negative 9 to get x plus 1. Taking the GCF, x squared minus 9 times x plus 1. And now we can also further factor this into using the identity that we did in the last slide, and a squared minus b squared. So the square root of x squared would just be x, and the square root of 9 would be 3. So we can factor this further into x plus 3 times x minus 3 times x plus 1, and that is the factored form. All right, guys, thank you so much for watching. See ya.